So for my final project,
Yes.
I really want to do a horoscope
Okay.
because it involves geography and time, and it also I would use some trig functions.
Okay.
So that's why I was asking about the date thing.
Oh, how to store dates, or
Or how to, yeah.
we're going to go over the library on time, because time's difficult.
I figured, yeah.
Yeah.
But like, I mean, it's a lot of really good math.
Yeah, that would be interesting from a time perspective, wouldn't it?
Yeah.
Yeah.
And also in order to get the output to put the little symbols and stuff like that.
Oh, well, there's a couple things you could do. One is we're going to learn how to use a GUI application, graphical user interface, and so you could position, have the code actually put image up there. Within text, it's kind of tough. If you find a font that maybe have that and play around with that, you might be able to find some fonts that have those symbols. But maybe the image thing. So there's a couple different ways of doing it. Is there a database or a file thing aspect to it?
I haven't looked yet.
So yeah, I think in terms.
I've been studying it by hand to see what it looks like on the inside.
Yes.
So I can get the numbers, you know, to know where numbers need to go. And now I'm just trying to figure out how to translate that into Python and make it.
Yeah, so there might be a way of like storing, or maybe once you get someone's horoscope, you can print it out to a file so that they have it stored somewhere, something of that nature.
Right. And like I found a couple of websites that have like all of the right, you know, transit aspects and stuff like that. So I just need to find a way to import data or a library.
Oh yes, that'd be perfect.
Yeah, and then get it to take pieces based on the user input and put it all together in a cool.
So when we go over files and databases, then you'll see how we grab information and do that.
Okay, so is that acceptable?
That sounds perfect.
All right, thank you.
Okay, so welcome. Let's see, everyone online, can you hear me? Cool, sounds like a microphone is working. So last time we basically we looked at numbers, expressions, how to get input with an input statement, how to print with a print statement, and you got your first assignment, which is to basically calculate a number of things out with for a pyramid. And so we get the base and the height from the pyramid with an input statement, and then we do some calculations and output with the print statement the results. Today we're going to look at something called sequence operations. And let me bring that presentation up. So this is in chapter 2, lists and tuples. And we're going to also look at things like indexing, slicing, adding sequences, and multiplication of sequences. And so what a sequence is imagine that you want to store a lot of numbers. Well, if you want to store 500 different values, would you want to type 500 variable names? That'd be kind of painful, right? So instead of doing that, what most languages do is they give you a way of storing collections, or as Python calls it, sequences. And these are often used to store, basically what are called data structures. And sequences can store numbers, characters, or even other data structures. And each element of a sequence is assigned a number, which is called its index number. So you have basically one variable name, and then using an index, we can actually store multiple values. So there's 6 types of sequences that we're going to look at, or that are primarily available in Python: lists, tuples, strings, Unicode strings, buffer objects, and X-range objects. The ones that we're primarily going to use are lists, tuples, and strings. And today we're going to focus primarily on lists and tuples. So lists and tuples are similar. They can both store a sequence of numbers or strings or any other values. But while lists can be changed after you create the list, tuples, once you create that tuple, it can never be modified. It's said to be immutable. So if you need to make modifications on something, you use a list. If you're going to make this sequence and then it just kind of stays that way from there on out, you'll use a tuple. And so there's all those different sequences. There's a number of operations which are common to all of them. So the things we're going to look at first are called the common sequence operations. So we're going to look at these operations which are common to all kinds of sequences. And then later on, we'll look at individual sequences that have specific operations which work on them. And the common sequence operations are the following: indexing, slicing, adding, multiplying, and checking for membership. So we'll go through these individually. So go ahead and open up idle and type this in. So we're going to say greeting equals hello. By the way, string is also a sequence. So some of the stuff we're going to be doing with strings, but you can do these things with strings or lists or tuples. And then type in greeting, open square brace, 0, close square brace. And what do you get?
H.
You get H. What is H? It's the first character of that sequence, H-E-L-L-O. Notice that we put in a 0, though. So it turns out that sequences are indexed starting with the number 0, not the number 1. We say that these are 0-based indexes. That work for everyone? So now try this. Put in greeting, which is the variable name for hello, and put -1 for the index. Yeah. And you get, what do you get? You get the O. So what do you suppose the -1 is representing?
The last one.
Yeah, it's counting backwards from the end, right? So Python does this sort of thing a lot. It says, hey, if 0 is going to be the beginning, what would -1 represent? Well, how about we just make it be, we'll use that to count backwards from the end. So that's kind of nice, because now if you want to get things from the end of the character sequence, you can get that. And otherwise, what you'd have to do is you'd have to add up the total number of elements and then index to that last element. If you want to go back 2, you'd have to subtract 1, and you have to do all this math. With Python, it's nice and convenient because you can just put -1, -2. In fact, if you want to try that, go and put greeting -2, and you'll see that it starts counting backwards through. In fact, you can actually just put the sequence itself down like that, hello, and just put square brace -1 and see what happens. And you still get the O. You wouldn't do this very often, because why wouldn't you just type O at that point? If it's just a literal. But just showing you that you can apply this square brace and 1 anywhere, and a value, and it will index it out.
Well, if you were going to create a program that automatically created an anagram,
Yes.
that would work.
Yes, you can. Yeah, you would be able to use the indexing to do it. Good example. So let's try this. We're going to say, oh, don't put raw input, just put input. That's raw inputs from Python 2. Just say fourth equals, let me see if I can type over. So if you do that, and then you put, let's see, it was 2019, I'll just put that because otherwise it doesn't make as much sense. And then type fourth. So you'll have to type in 2019. So the input statement basically prints out year and waits for input. And notice that it's only returning the last number because we put this index 3 here. So if you only wanted to grab the last element of an input, you could do that. You probably wouldn't do that that often, though.
It's not doing it. I tried it with this piece.
Oh, now type fourth. So it stored it in the variable, then we had to.
Okay, so yeah, I named it, and then I had to call them.
Yes. So it's just showing that you could index, off of directly off the input. And so, the square brace 3, close square brace took really the fourth element because it's, it's 0 index. So we're going to look at listing 2.1. If you go to, let me bring open, in the chapter 2 learning modules, I believe, yep, there's day 3 sample programs. So we're going to download those sample programs, and once you have it downloaded, go ahead and extract.
Wait, do I need to do that on here?
And let's look at listing 2-1. In order to open a file, right-click on it and edit with I. Is everyone able to open that? So go to Blackboard. And then in Learning Modules, Chapter 2, you'll see day 3 sample programs. And then are you finding the zip file?
I'll get there.
And then edit, and then if you double click on it, it's just going to run the program. So what you want to do is right click on it and select edit with idle. That open up for everybody? Were you able to find it? Were you able to find it back there?
Yeah, I'm just having problems with it opening it right now.
Okay.
Yeah, it like,
Keeps erroring out for some reason.
Did you right click and open with idle, or did you just run it?
Yeah, well, I'm in idle right now, it opens there, but when I try to run it, it just logs out and doesn't go into the program.
Huh. So let me see if it runs. Oh, you know what it is? Is this one's written in 2.7. We need to.
Yeah.
I need to get the 3.0 version. Let me see if I can find it. Okay, I think it's just going to be easier for me to fix this. So wherever you see raw input, change that to input. And where you see print, we're going to put parentheses around the thing that's being printed.
Has the raw input function completely gone away in the new Python?
Yes.
It's just input now?
Yeah, input is the same as raw input. So everything gets input as strings now, and I think this should work. Yeah.
I still can't get my this started.
Okay, so I'm going to run this program. And if you put it, the way this program works is if I put in a year, let's see, 2020, and then the month is 1, and the day is 22, it will convert that into January 22nd, 2020. So then the question is, how does it do this? Well, first what we're doing is we're making a sequence here. With the which has a list of months. And you can see that we have January all the way through December. What's January up here? Which index number is January?
0.
0. And then here we have this interesting thing going on here. So we have STNDRD plus, and notice that we have 17 times TH. What that's doing is it's putting 17 THs one after the other. So it would be almost equivalent of saying something like this. So it's all of these. And then we're adding 17 THs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So someone didn't want to type that all out, so they just put 17 times TH. Does that make sense? And you notice that we have this plus. This plus says take this list and concatenate it with this list. And then we have, again, ST, ND, and RD, and then we have 7 of these THs again. And then we have another ST. So what do you suppose the idea is behind that?
First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th,
Yes.
12th, up to 31.
Yes, we are making all the endings for the numbers up from 1 to 31. But rather than typing this all out, we can just use 17 times to do the ones that are repeated over and over again. Make sense? Does it make sense online? And then what we're doing here is we are getting some inputs. We're asking the user for the year. What does input return? A number or a string?
A string.
String. So it's just going to be the text 2020. It's not going to be the actual number. Same thing with the month. It'll be when I type in 01, or when I type in 1, it's going to bring in just the character 1. When I type in 22, it's going to bring in 2 characters, 2 and 2. So these are going to bring in strings. Then we have, this is a conversion function. We're saying, hey, take month, which is a string, and convert it into the actual numeric value as an integer. And there's another one for float, which will take a floating point number and convert it. We're going to use the integer one here. And then we're going to use the integer function to convert day, which is a string, into a number. And so now we get month number and day number. Now what we have is we're going to go to this sequence, months. And what we're going to do is we're going to say, take the month number. So I put in what? I put in 1, right, for January, and subtract 1. So what's 1 minus 1 is 0. And go and index out, therefore, the 0th element of months, which is January. Start to see how this works? And so January gets stored in month name. And then we're going to take day number, which is, what I put in? I put in 22. 22 minus 1 is what? 21. And we're going to say, take endings and take the 21st one. So I go 1, 2, 3, and 17, 18, 19, 20. It's going to get the ND out of there. It's a 22nd one because, remember, ST is 0, right? And then we move up to the 22nd one, which should be ND. And so we get ND, and then the day was originally 2, so that's 22nd. So this ordinal ends up becoming 22nd. Does it make sense? So now we have the month, which is January, and we have ordinal, which is 22nd, and we print out January, the ordinal, which is 22nd, and then the year, 2020. Now, the way you can do this, work with these kinds of programs, is what I call paper compiling. Normally I do this on the board, but since we have people online, we're going to do this with Notepad. And so the way I do paper compiling is I put variables and output, maybe. I'll use another notepad. I usually do this on 2 sheets of paper. And then I go and and just looking at the code, I say, okay, declare a variable called months, and it's going to be, this thing. So that goes into memory. And then we created endings, and it's going to be basically, and then I would calculate this all out. And I would do this on paper. And then, okay, make a variable called year. And at this point, I have an output because it's going to say year, colon, and it's going to wait. And I say, okay, well, at this point here in the code, what's going to happen? Okay, I'm going to type in maybe a value, 2020, which means that then this one is going to be, and notice I put the there because I know input brings in as a string, it's going to store it in year as a string. So I put that down. Now I go to the next line of code, month. Say, okay, month is going to equal, and I'm going to get an output because this creates an output. So down here, where I have output, I say it's going to say month 1 through 12, and it's going to sit there. Well, okay, so my example, I put 1. So that means 1 as a string is going to go into month. Then I say, okay, now I'm on the next line of code right here, and it's going to say day equals, and again, at this point, it doesn't have the value yet. It's going to ask it by saying day 1 through 31. So it does this part about putting a value because of the input statement. And then as the user, I put in a value. So you can see what I'm doing is I'm running the code as if I'm the computer. The computer isn't running this. I'm doing this, right? So now 22 as the string goes in here. It's very important as you do paper compiling to make sure that you use the right nomenclature. If it's a string, write it down as a string. If it's a number, write it down as a number. And then, okay, now we have month number. So I'll write down that variable. That's coming in. And let's see. It's going to equal the integer of month. Well, now it's cool because if I write it down, I can look up here and see what's month. Month is the string 1. Just pull. So now it ends up becoming the actual number 1. And then we're going to this next line of code here. And in that case, we now say day number is equal to the integer of day. I look up here, and the tendency when you're doing paper compiling is just say, oh, I know what that is, and just write it down. Make sure you go look at the actual value. Make sure you actually look at the operation. Integer of that is going to be the value 22. Now I come down here, and we create a new variable. Month name is equal to, and it's going to be months, which is this one right here. And we're going to take months, and we're going to look for month number. Month number is 1 minus 1, so that will be 0. I'll take 0th element, which is January, and month name will then therefore be January. Does that make sense? Why did they put the -1 in there?
January 0.
Yeah, because it's 0 base. Because the computer is, yes, Richard. The computer is 0 indexed, but people are 1 indexed. And so when you're programming, you're constantly subtracting 1 from what they are for an index, and you're adding 1 when you're telling them what an index is, because human beings don't deal well with the 0th element. So now we've got the month name, and then we want the ordinal. And the ordinal is going to be, take the day number, which we can see right here is 22, subtract 1, which is 21, and then we're going to count 22 over, which will end up being the ND. And then we take that and put it after day. Day is 22. So that will be a string, 22 with the ND. Does that make sense how that works? And then we do the print. We're going to print the month name. I look it up. Month name is January. And then we have a space. So you can see this is a space. Then we have the ordinal, which is 22nd. And then we have a comma and a space. And then we have the year, which is the string 2020. So we just paper compiled this program, and we got the same result as is that the same result as we got here? Pretty much letter by letter, character by character, right? So this is called paper compiling. If you can paper compile a program, then you are able to do the same thing. You understand how the compiler works. So it's the So you can, the front matter of your book actually gives a reference to where all the programs are located for this book. I recommend is as you're going through the chapters, grab the programs, grab 2 sheets of paper, and go through the program line by line and write down the variables and then write down the output and see if you can do it. Then run the program and see if it gives you the same output. You can do that, then you start learning how the compiler thinks. When I started learning programming, I didn't have a computer. That's actually how I learned how. And then I found out a year later that they had a PDP-11 computer in my high school, and then I was able to put my program. I write my pseudocode, I write my code, I then paper compile it, make sure it works, and then when I got to the computer room, I would take my code, put it in, and verify that it would work, and then make programs. So it's still a really good way to learn.
The woman who helped them put man on the moon wrote
Yes.
the code by hand.
Yes. When I saw that movie, I saw them get that book, the Fortran book, and that format of the book, just the size. Mine said Basic Fortran and COBOL. It was the same book or same format of the book. It was like this, that was an awesome moment. It's like, okay, I get it. And then when they had the one computer and they had about 12 mathematicians, which they were going to do coding. She had to train them all. I'll bet you that when they're training, that's how they trained, is they wrote it all out by hand.
Mm.
Okay, so let's see, where are we at?
This is day number is an integer.
Yep, so just do that. Okay, so the next up, so that's the index. We can use it to look, given an index number, we can look up a value in a sequence and retrieve that value. That means that we can then make a single variable that can store a large quantity of elements, and we don't have to have a lot of variables in order to store a large number of values. So let's try this. Let's make this string. Type this string in tag is equal to, and this is called in HTML an anchor tag. We're just using it for a convenient way of accessing some text, and also because later on we're going to learn screen scraping, which means how you write code to read the internet. And so this is called an anchor tag. And what it is the href is actually the web address that when you click on a link, it'll go to. And where it says Python website, that's what the link would actually show on the web page when you display it. Anybody here do HTML? Don't worry about the actual. And then when you get done, notice that we're doing something that looks like an index, but it's a square brace 9:30. And tell me what you get when you get done.
Python.org or HTTP. Why Python? Where's the H?
Oh, I have TH on mine. Did you type it? Did you miss the H in yours?
Yes, I sure did.
You can copy and paste in either, by the way. So we'll probably grab an extra character at the end, possibly. So you should have gotten the the URL part, the http://www.python.org. This is called slicing, and what it means is I'm going to take, I want the characters 9 through 30 of this bigger sequence. So we have the sequence of characters called tag, and then we want just the element, we just want the 9th through the 30th one. Now, if you look at this, what I've done is I put, kind of turned it sideways so that, because we have double digits, but the 9, you'll notice, shows up on the H. Which character is at position 30?
0?
This quote, right? This double quote after org is actually the thing that's at position 30.
Is that just so it'll recognize that it's a complete string?
Yeah, well, within this is just the syntax for an anchor tag. They put the URL between two quotes. But within our string, it's the whole thing is delimited with a single quote at the beginning and the end. And so this is actually one of the characters. But you notice that in the result, the double quote didn't show up. And the reason is that when you do a slice, the first digit is included, but the second number is not included. So it only got to the G in org. So you're going to see this pattern whenever you see a range in Python. The first number is included, the second number is not included. Does it make sense? So inclusive, not inclusive. And it's just because from a programming perspective at a lower level, it's just easier for the code to work that way. But there are some of these idiosyncrasies we just have to get used to. We have to kind of get used to. Now try this one. Say tag 32:-4. So this is going from the 32nd element to the -4 element. And then before you hit enter, try to predict what it's going to take from the string. And I've given you a little chart there to help you find it.
Me?
Yes, Antonio, the video is being recorded, so you should be able to get it when you get back. So what did we get? Python website. Notice that the 32 lines up with the P, and the -4 is -1 is actually at 50, -2 is at the A, -3 is a slash, and -4 is this less than symbol. But because the second element is not included, it will stop before it gets there and just get back Python website. So the first digit in a slice is included, the second digit is not included. It's one passed. Make sense? Now let's try this. Put in numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34.
Keyboards are tiny.
And then you have that. Put in the slice numbers 7 to 10, and before you hit enter, try to predict what you're going to get. And then type enter and see if you got what you predicted. So remember, the first number is included, the second number is not included. It'll be one before that number.
So really it's the numbers, the 7th, 8th, and 9th numbers.
Yes. So you should get 13, 21, and 34. So the 7 will point to that 13, and the 10 would actually point off the end, right? One that's not there is off the end, but because it goes to the one before it, that's how you have to index the last element, because you have to go one beyond it. So 10 is exclusive, so we get the 34. Now, using the backwards numbering scheme, let's see if we can get, with the minus numbers, let's see if we can get the last 3 elements with that. And so you might put in numbers -3 to -1. What do you think we're going to get? Do we get all 3 of the last numbers? No, because that second number is not included, right? So if we put in -3 to -1, we get 13 and 21, but we can't get 34. So the question is, how do we get to 34? Numbering from the back. What? Well, we could try that. In fact, that's what the next one is. So let's try numbers -3 to 0. Well, what's 0? It's the first element, right? So you get the empty list, because it says, hey, I'm at -3. Oh, wait, I'm going back the wrong direction now. And so it says I've got nothing, and returns 0. So
it reads 0 and -0 is the same, because they are the same.
Yeah, oh, so you tried -0? Yeah, that's a good idea. That could have been actually a smart way to put it too. The thing is that actually, these are all conventions. There's no right or wrong answer how the programmers, when they built Python, could choose to do this. So we're really just exploring what they chose to do to define this language. What they chose to do is say, hey, you know what, why don't we just leave an empty element? If we put -3 : and don't put anything after that, that means to the end. And so, so a colon with nothing after it basically says, hey, go from the previous number all the way to the end. So I just read that as to the end. Make sense? What about this? What if I said nothing : nothing? Well, if on the right side nothing means to the end, what do you suppose nothing on the left side of the colon will mean?
From the beginning.
From the beginning to the end.
Which would be handy if you're increasing the list by user input and you don't know how many will be in the list.
Yes, if we're bringing in something from, maybe we're reading a website or grabbing information from input or reading a file, we don't know what it's going to be, the counting from the right side is extremely useful. So let's look at listing 2.2. We'll paper file that one. So in this code, we're going to see URL raw input. We're going to change that to input. And then put my parentheses for print statement. And then let's see what this runs like. I'll make this a little bit bigger so we can see it. So first of all, we have URL. So we declare, so we get the URL variable. And then we have an input statement. So it's going to say, please enter this URL, and that's going to go here. And so I'll put www.cnm.edu. And that means that that is going to be stored in URL as a string. Does that make sense? That's basically what our input statement does. So now the next thing is well, we're going to declare a variable called domain. And it's going to equal URL, which is this. And we're going to go, actually, I made a mistake. I need to put in http:// This is dependent on that being in. So now we're going to go from 11 to -4. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is this C. And we're going to go to -4. So -1, -2, -3, -4 is the dot. Would you all agree that basically what we get is CNN?
Mm-hmm.
So now domain gets that. And then we say print domain name. So this goes into the output. And it's going to print this. Does that make sense what that's doing? And then we'll just run it. So, and then see, www or http://www.cnm.edu, and we get CNN. And does that output look the same?
Mm-hmm.
So that's how that program works. Does it make sense? Does it make sense online? So let's try the, okay, so yeah, this is this code. So now let's try this. You may have this line of code already up there, you can copy and paste it, or just type numbers and see if it's still in your, if numbers still exists. If it does, then you don't have to type this whole thing over again. But then try numbers 0, 10, and 1. and you should get the whole thing. And what that 1 is the sequence number 0, 10, and 1 is the same as 0 to 10. The last parameter is the step length, which tells Python how many elements to skip each interval. So if omitted, basically it defaults to 1. So if you put 1, it's the same thing as just putting the slice in, and it'll display everything. Now try this, put 0 to 10 in steps of 2. And what did it do?
Gave us half the list.
Gave us every other one, right? So now you can jump through the list in pretty much what you want. Try this one, 3 to 6 and 3, and try to predict what that's going to produce before you type it in. I mean, before you hit enter.
Did you say 3 to 6 by 2?
3 to 6 by 3. In steps of 3.
It's going to give us the 2.
So the first element, the 0 element.
Right, but so between 3 and 6, it doesn't include 6.
Correct.
So there's only one instance of a multiple of 3 hitting in that.
You only get the 1 element.
Mm-hmm.
And then try this one. What is this one saying really?
The whole list by 4.
Yep. From the beginning to the end in steps of 4.
Which again, if you start the list off with 4 things, but a year later there's 4 million things.
Yes. So a lot of this is basically is being able to describe an algorithm in the most succinct way possible so that it can be used on multiple different instances. And so there we get the first one, and then we skip over 4 more, we get the 3, we skip over 4 more, we get the 21, and then we don't have enough to go 4 more, so we're done.
Is there a way you can make it loop through by 4s?
So loop for the,
Like so it doesn't have enough to.
oh, so it rolls back around or something? Yeah, but then we would have to get into actually writing loops and conditionals and stuff.
Mm-hmm.
So there are limitations. You can't quite do everything with slicing, but you can do a lot. For example, you can go backwards here. So notice when we go backwards, we're going 8 to 3 by steps of -1. Notice in this instance, the first number is larger than the second number. And basically reverses the list from 8 to 3, index 3, which is. Why doesn't it include the 2?
Why does it not include the 2?
Yeah, this 2 is at index 3, so why doesn't it include this?
Because it doesn't include the second number.
Right. It's still inclusive exclusive. So it still doesn't include the second number, even though the second number is now before the first number. It's still this position not included. And then if we can go from 10 to 0 in -2 increments, and that's when we get the whole list except for the 0th element. It's not included.
0. Congratulations, Shakespeare just rolled over in his grave.
Yeah, programmers have to create grammar sometimes. And then from 0 to 10 in -2 increments, -2 increments. So the question is Okay, so now we have, the first number is a smaller one, the large number is the second one, and we're going to -2. What do we think is going to happen?
Because you can't go backwards and forward moving vehicle.
Yeah, we're going to get the empty set because it's going to start at 0, it's going to jump back -2, say, okay, this doesn't exist, you know, this, we're now done. And so it's, nothing gets returned. And then we're going to go from the beginning to the end in -2 increments. Is that what that's going to do?
Oh, hold on.
So is that beginning to end in -2 steps?
But it won't work.
So go ahead and type it in and see what happens. Python is actually smart enough to figure out that if you're going in minus steps, it's not going to interpret that as from the beginning to the end, but interpret that as from the end to the beginning.
So throwing the negative in there told it to go right to left.
Yes, so often Python just kind of does what it tells it to do. In this case, it actually, the programmers made it smart enough to figure out what to do.
So if I wanted to teach it how to accept user input in a different language that goes from right to left, I could use that.
Yeah, you could possibly use that in languages that are that way to reverse the list necessarily. Because in our program we would be we're still kind of left to right oriented. You might store your once you tokenize all the language and turn it into individual elements, you might store it, you know, from left
Somebody's
to right.
already done that.
Yeah, no, these.
I would import that.
It's really rare to find a problem that is not a solved problem anymore. What we're mostly doing is taking solved problems and recombining them into new things. So try this one: 5 to the end and -2 increments. Is that 5 to the end or 5 to the beginning? 5 to the beginning, because it tells, because it's -2, it figures out that okay, I should go the other direction.
So the double colon is just go through the whole list from here.
Yes, and
if you don't specify from where here is, it will choose from here
the most logical.
based on whether you want to go left or right.
Yes, and like in here, we're going to go from the end to 5 in -2 steps. So it's 34, then -2 is 13, and then the last one is not included. That kind of makes sense? So let's take a break. We'll come back. We'll continue on at 40 after, and we'll continue with sequences.
I'm actually going to take off from here and finish the rest of the class later.
Sounds good.
Okay. This was fun.
Sure.
Yes, I'm using this book because I already had it. So.
Okay. Yeah, that should be fun. You can access the actual book online too. So.
I have a question.
Yes.
I've done some of the 2D Python stuff, so I think I'm getting my own way. Would you come look at
Sure.
what I have?
Are you typing in raw inputs and
Yeah, I've
putting
got some
in,
program 2 I've been working on,
and then that
I'm using the
inputs?
ASCII, the old ASCII. Let me show you. It's on the state information. So,
Oh, okay.
I think this is where I'm getting bogged down in the capital to reference the string. I'm looking at the new code.
So you don't need to use if-statements to solve this problem.
Okay, so this is what I've got set up so far. I just kind of running my head here, so I just got it set up.
Yeah, you create your states, and then you create your capitals and your districts, and
All that.
what's the join one?
That's when they joined the,
Join the, okay,
Yeah.
yes.
yeah, joined the,
Are you using dictionaries?
in this one I was, yeah. So I've looked, I've been.
Yeah, you're way beyond what
Because I was looking, online for exactly what other people did.
Right.
So,
So you don't really need this to be dictionary at this
Okay.
stage. In fact, it kind of breaks the paradigm that we're trying to use. So what you do is you make these all in the list, and then we're going to find there's a function called the index function.
Okay.
See you next time.
So I'm good up to here, but then when I get down to here is where.
Well,
Is this okay how I got this set up?
no, well, you could make that work, but the way that, at this stage that a student would have is they would make capitals be a list,
Okay.
districts be a list, join be a
So
list.
just like this, do them all.
Yes, yes. And then what you would do is you'd ask the user for which you would display the
Yeah.
states, you'd ask which state they want, and then there's an index function.
Okay,
And the index function will return the index of whatever the string that you pass to it
okay.
in the list. Once you have the index in the state, then you can take that index and using the square braces, you can get the other three values. So then you would
I'll
say,
look into the
then you say
index function.
capital square brace, whatever you got is the index
This
number.
is, what because I've done some of this before and I have friends
Yeah,
who
yeah,
do
yeah.
it, so these are kind of the directions they pointed me in when I started writing it, so I guess I was just, and now that they switched from 2 to 3, it's really got me screwed up in my thinking.
Well, none of that really, there's very little that's going to affect this course on
Okay.
3, because the primary thing is print statements in 3 use parentheses.
Okay.
And input is the same thing as raw input. That's primarily the key differences between 2 and 3.
Reminds me.
I have a question.
Yes.
How do we round off numbers to 3 decimal places?
There's a round function.
Yeah, I was trying to mess around with that. I couldn't figure that out.
Let's see.
Okay.
And the cool thing is there's something called IntelliSense. You notice how this pops up and it kind of tells you what the function does, round the number to give in decimal digits, and then tells you what the parameters of the function are. So here's his number and then number of digits. This is a default. It says if you don't put anything, it'll say none. So if I put number like this, see, it just rounds it off to
Okay.
0. Okay, so the next thing we're going to look at is adding sequences. So when we add sequences together, Notice we have a list here plus another list. Go ahead and type that in and see what you get. You should get one list that says 1, 2, 3, 4, 5, 6. Does that work for everyone? So this addition is not really doing addition in a sense. It's really doing what we would call concatenation. It's concatenating, or basically adding this one sequence to the end of the other sequence. It does the same. Realize that a string is also considered a sequence. It's considered a sequence of characters. So when you add hello with a space plus world, notice that you can actually concatenate two strings together. So this is concatenating strings is useful when you're putting a whole bunch of things together to put together an output, and the plus operator acts as a concatenation operator as well. Does that work?
That or this.
That.
Me.
That work online? Now, let's see if we can concatenate a list with a string. Go ahead and try that and tell me what happens. Yep, you get an error. And the fact of the matter is you can't concatenate things that are not the same. Either both have to be lists, both have to be tuples, or both have to be strings. Next operation is multiplication. So with multiplication, you can take we're going to take a sequence, Python, and multiply it by 5. What do we get? You get lots of Python, right? Yeah. So you can use that. Can sometimes be convenient when you're trying to initialize a variable. Like if you wanted a string with a bunch of spaces, sometimes that would be a useful one. Let's try this. We're going to take the list 42 and multiply it by 10. So we get 420. What you should get is a list with 42 elements in it. And this is often, again, used to initialize values. So what if we want to create an empty list of 10 items? And let's say we had a room, we had 10 rooms on this floor. We wanted to keep track of their temperatures. Well, one way we can do that is we could use this keyword called none. None is not 0. It's actually the absence of an actual value. Some other languages call it null. And so if you make you can say create sequence is equal to none times 10. And then what you get is actually kind of a whole lot of nothing. You get a list with 10 nones in it. This is a perfect list for then if you want to go collect data to put the values in the different positions. And we would know that, for example, if we put zeros by default, and let's say we then took the average of that, and then we used that to control the air handlers in the building, what would happen to the temperature if we didn't collect the data from all the rooms? Well, we'd be averaging at 0, right? So if half of the numbers were 0 and half the numbers were, say, 72, it would think that the temperature was actually 35 degrees. And then it would turn on the heaters to bring the temperature up to 72, and you would have really warm rooms. So none is a very important concept from a data collection perspective. If you don't actually have a value, you want to use none rather than 0. So let's look at program 2.3. So in this program, we're going to start off by first line 1, sentence is equal to, and we're going to, let's change this to an input. And then we need parentheses. So we're going to ask for consent from the user. I'm lazy, so I'm just going to put hi. And then we get these other variables that come in. Screen width ends up being 80. Text width is equal to the length of sentence. So what's the length of it? So this len will actually take a sequence and return back to you the number of elements in that sequence. So how many elements are in this sequence called sentence? 2. The elements between the quotes. So that len will, and you can do this with lists and tuples and anything. Then we have box width. Box width is going to be text width, which is what? 2 plus 6 here, so we get 8. And then left margin is equal to screen width, which is 80, minus box width, which is 8. So we're now at 72. And we can just do that here. Divided by, actually, no, we do want that. Divided by 2 will be, so we had 72 divided by 2 is 36. Oops. Over here, 36. And now we get some print statements. So we get a print here, which goes down 1 character. And then we're going to take a space times left margin. What's left margin?
36.
36. So we're going to get 36 spaces here, because that's a space between 2 quotes. So I'm not going to count them all out. And then we get a plus, and then we add a minus, times the box width minus 2. So the box width is 8. So we're going to print out 1, 2, 3, 4, 5, 6, 7, 8. But it said minus 2, so it's actually 6 of those, right? And then we get a plus. Then on the next line, we're going to space over our 30, 36 spaces, and then we have pipe character, which is this vertical character. It's over the enter key. And then we have a space times the text width, which is the space. Oh wait, we got two spaces here first, and then we got the spaces times the text width, which is 2 spaces, and then we got 2 spaces and a pipe character. Then again, we get our, here we get our 36 spaces to the left, another pipe character with 2 spaces, and then we have sentence. Sentence is hi. Then we have 2 spaces and that. And then if you notice that these 2 lines of code are the same, right? So it's going to look the same. And then this line of code is the same as that line of code. So here we're going to get our 36 spaces, our plus, our minuses, and then our plus. So what does this code do? Makes a box, or whatever you type in.
Yeah.
So if I run this, and it also centers it automatically. Console is 80 characters long. Does that make sense how that works?
Yeah.
So this is using the multiplication. This is using calculation in here. Let's see what else. So, next thing we're going to look at is this thing called an index method. So make a sentence, knights equals this list, and inside this list we have some strings. We are the knights who say ni. And we're going to then use this method called index. It's called a method as opposed to a function because notice that knights is a list or a sequence. And we put the dot operator, and then we have a function here that really only works with sequences. So when you have a method, it's usually applied to something. So the index method is being applied to knights. And what we're doing is we're going to, when you run this, what you will get is it will return this number 4. 4 is the index number of where who shows up in the list. Notice we is 0, R is 1, 2, V is 2, knights is 3, and who is 4. So this is kind of the reverse of using the square braces indexing to get something out. To find out what something's index is inside the list, you can use the index method. Does that make sense? Now let's see if there's Harry inside of this list of knights. What do you get? We get an error, right? So if the list isn't in there, if the object isn't in there with the index method, you're going to get an error. Make sense? You can also kind of mix and match stuff inside of a sequence. So try this. Put Edward is equal to Edward Gumby 42. John equals John Smith 50. And then we're going to make a database which has both Edward and John in it. This is actually a list which has 2 other lists in it. And if you were then to display database, you should get a list with two lists in it. Inside the list, you have a string and a number. Did that work? And this is sometimes used, so you can actually nest these lists and sequences and everything together in order to make more complex data structures. So in this case, this approach is sometimes used when you have, like in this case, you might be making a phone list or something. It can be one way of storing your information. And Python's pretty flexible. So we went over the common sequencing operations, which included indexing, slicing, adding, and multiplication. Sequences are one of the things that make Python pretty powerful. You can very easily represent very complex data structures with it, and you can write very succinct code to kind of access things in your sequences. And so next time we'll go over some sequences some more, but that's all I have for today. So the rest of the time, if you have questions on your programs, let me know. Online, did you have any questions I didn't cover? Cool. So let me know if you have any questions online, and the rest is lab time.